Hello everybody, welcome to the very first video of the subject soil mechanics, and today we shall begin our discussion with the very first topic in soil mechanics, that is the properties of soil. So getting straight off to the topic now, talking about the properties of soil. Now if I ask you all to go out and get a mass of soil, now that mass of soil is not only going to consist of the soil particles, but along with the soil particles, in the voids, that is in the spaces, you will find water and air as well. Okay, so from the diagram as well, you can see these are the soil particles. These are the soil particles. These are the soil particles, and in the voids you will find water and air as well. Okay, so in the voids you will find water and air as well. Now due to the present, this whole thing is a soil mass. So this is a soil mass. Okay, this is a soil mass. So soil mass is nothing but solids plus water plus air all together combinedly, it is called as a soil mass. So due to the presence of soil particles, okay, in the soil mass, few of the properties of soil will be similar to those of solids, which we deal in solid mechanics. And due to the presence of water in the voids, few of the properties of soil will be similar to those of fluids, which we deal in fluid mechanics. So in short, we can say that, okay, the properties of soil, some of them are similar to those of solids, which we deal in solid mechanics, and few of them are similar to those of fluids, which we deal in fluid mechanics. That is, they lie somewhere between those of solids and those of fluids. So this was just a brief introduction for you all to know what would be the type of properties that we would be studying in this subject. That is, properties would be, some of them would be from solid mechanics and some of them would be from fluid mechanics. So this was just a brief introduction. So before we start taking down the note points, I would also like to mention the name of a very prominent person, that is Sir Carl Terzaghi. Carl Terzaghi has made tremendous contributions in the field of soil mechanics, and that is the reason why he is called as the father of soil mechanics. So let us just kickstart the subject by mentioning his name. So let us write down the first note point. Okay, so the first note point would be Sir Carl Terzaghi. Sir Carl Terzaghi is known as the father of soil mechanics. Sir Carl Terzaghi is known as the father of soil mechanics. Let us also write down the other point which we just mentioned, that is, the properties of soil. The properties of soil lie between those of solids and those of fluids. That is, some properties will be similar to solids due to the presence of soil particles, and some of the properties will be similar to fluids, which we deal due to the presence of water, which we deal in fluid mechanics, and solids we deal in solid mechanics. I hope the points till here are clear. Okay, so before we advance into the next topic, that is the formation of soil, okay, I would like to tell you all the difference between a soil mass and soil solids, because we have seen learners getting confused between these two terms, that is soil mass and soil solids, and these two terms are being used quite often all throughout the subject. So in order to avoid the confusion, let me clear the two terms here itself. So when we talk about soil mass, okay, whenever we say soil mass, If you'll remember, I started the subject, okay, or I started this video with a sentence saying that if you go out and if you bring a mass of soil, that mass of soil is not only going to consist of the soil particles, but along with the soil particles you will find water and air as well in the voids. So a soil mass is basically a combination of soil particles, air and water. That is, it is a mixture of the three constituents, that is soil particles, air and water. So we can say soil mass is equal to solids because soil particles are also called as solids plus water plus air. Now if we talk about if we talk about solids, okay, or if we talk about soil solids, it refers to only the soil particles, So whenever we say solids or whenever we say soil solids, it refers only to the soil particles. Okay, I hope the difference between these is clear. So let us now talk about the formation of soil. Okay, now talking about the formation of soil, now if you all ask me the question, how is soil formed? So the simplest answer to this question would be soil is formed by the weathering of rocks. Weathering in the sense disintegration of rocks. Okay, disintegration is nothing but the rock disintegrates or breaks down into smaller finer particles, and that ultimately leads to the formation of a soil. So why does this disintegration happen? Now the disintegration might happen because of physical agencies or due to chemical agencies. That is, either physical agencies such as, okay, let me write down the physical and chemical agencies. That is, soil is formed by the disintegration of rocks, okay, and disintegration is caused by either physical agencies such as running water. It could be running water, it could be wind, it could be gravity, or it could be ice, anything, okay, etc. It could be either due to physical agencies or it could also be due to chemical agencies. Okay, chemical agencies could be oxidation. What is oxidation? Oxidation is nothing but the reaction in the presence of oxygen. Okay, oxidation, it could be due to reduction. Okay, it could be due to carbonation. Reduction is nothing but the reaction in the absence of oxygen. It could be due to carbonation, or it could be due to leaching. Carbonation is the reaction with carbon dioxide. Leaching, what do you mean by leaching? Leaching is the process in which the fine and suspended particles, as well as soluble particles of the rock, okay, are washed away by the action of running water. I repeat, washing away of fine, suspended and soluble particles by the action of running water is called as leaching. Okay, leaching, it could be anything. Okay, now talking about the physical agencies, talking about running water, so you all can see it from this figure. Now just suppose that there is running water over here. Now when there is running water, what happens is, due to this running water, a frictional force is generated at the interface between the running water and the rock, and due to this friction over a long period of time, what happens, the soil particles, the rock, okay, fine particles of the rock start disintegrating, or they start getting separated out from the soil due to the frictional force, and this ultimately leads to the formation of a soil or soil mass, you can say. Now if we see this portion of the rock, okay, if you see this portion of the rock, suppose there is air blowing here. Let me take another color. Suppose there is air blowing on over here, okay, or wind. Okay, there is a strong wind blowing on. This wind will have a long-term impact, okay, on this rock, and due to this long-term impact, what happens is the rock again starts disintegrating. That is, fine particles of the rock start separating out from the rock, and this ultimately leads to the formation of rock. Okay, similarly gravity, ice, etc. Now we have one more concept here. Okay, that is, if the soil that is formed, okay, suppose the soil is formed here, okay, due to the disintegration of this rock, soil is formed. Okay, soil is formed. Let me show the soil here. Okay, now this soil, if it remains there itself, that is, it is retained on the same parent rock, if it is retained on the same parent rock, then such type of soil is called as a residual soil. Okay, if the soil is retained there itself, it is called as residual soil. But suppose, okay, there is a strong wind. Okay, let us change the direction of the wind here just for our convenience. Now suppose the wind is blowing in this direction now. Okay, there is a strong wind blowing in this direction. Now what happens, due to this wind, these soil particles, they don't stay here itself. By the action of this wind, these soil particles are transported and they get deposited somewhere here. They get transported and get deposited over here due to the blowing of strong wind. Now when the soil is transported and it is deposited elsewhere, okay, it is not retained on the same parent rock, but it is transported and deposited elsewhere, okay, then such type of soil is called as transported soil. Okay, such type of soil is called transported soil. Transported soil, we could find it here as well. Okay, by the action of running water, the soil particles are carried away with the running water, and these soil particles are deposited somewhere else. And when they are deposited somewhere else, okay, such type of soil is called as a transported soil. So let us write down the note points till here. Let me erase this. We'll write it in a better way. So we can say that, yeah, the process or the soil is formed here. The soil is formed. The soil is formed due to weathering. Weathering, into bracket we can say disintegration, is formed by the weathering, that is disintegration of rocks. Disintegration of rocks, which may be due to physical agencies, such as running water. Physical agencies could be running water, or it could be wind, it could be ice, it could be gravity, etc. Or it could be due to chemical agencies, such as oxidation. It could be due to oxidation, it could be due to reduction, it could be due to carbonation, or it could be due to leaching. It could be due to leaching, or it could be any other chemical factor, okay, etc. So now, if the weathered rock, or if the soil, if the weathered rock material is nothing but the soil. if the weathered rock material is retained over the same parent rock, then such soil is called as residual soil, but if the weathered rock is transported and deposited elsewhere, then the soil is called as transported soil. Okay. Now whatever we have discussed in the above topic, that is the formation of soil, we can represent it in the form of a cycle, okay, just for us to remember better. So in the cycle, okay, the first process in the formation of soil would be weathering. So the first step would be, or we can write it here, okay, steps involved in the formation of soil. So the very first step would be weathering. So the next step would be, when the rock has been weathered, what happens is, it either, we can show it from the diagram. So when the rock is being weathered, okay, and soil is formed, now this soil can either stay here itself, or it can get transported and get deposited somewhere else, okay. So we can write the second step as transported or transportation. So the third step would be, now when the material or the rock, material or the soil is being transported, what happens? It gets deposited here, okay. Now so it gets deposited, and after getting deposited, okay, what happens is, after getting deposited here, okay, over a period of time, more and more soil particles start getting deposited here, okay, over a period of time. And ultimately what happens is, it forms a heap like structure, you can say, okay, or it forms a upheaval due to the deposition of more and more soil particles over a period of time. So the fourth step would be upheaval now. So it would be upheaval, okay. Now this upheaval is again subjected to weathering, okay, due to the presence of wind or water, okay. This upheaval is again subjected to the same, okay, that is weathering. So it is again subjected to weathering, okay. So this was the cycle of formation of soil, okay. Now the entire process, whatever I'll explain to you all, okay, in the above steps, or whatever I have explained to you all in the formation of soil, the entire process of formation of soil is called as pedogenesis. Okay, very important point, that is the process of formation of soil. The process of formation of soil is termed as pedogenesis. Okay, pedo is termed as pedogenesis. Okay, so we are done with the topic of formation of soil now. Okay, so let us now move on to the next topic of this chapter, that is the types of soils. Okay, so let us write down the heading, that is types of soils. So in this topic we are going to categorize the set of first 6 soils, okay, or we are going to categorize the first set of 6 soils on the basis of their mode of transportation. That is, we are going to categorize them on the basis of how they are being transported from their place of formation to the place of its deposition. So let us write it in a form of a table. That is, we shall write the name of the soil here, that is soil. Then since we are categorizing them on the basis of their mode of transportation, we shall write transportation agent here, transportation agent, and thirdly we shall also write where they are found at. We shall write where they are found at. We shall write it in the form of a table. So here we shall write the name of the soil, and here the transportation agent, and here lastly where they are found at. Okay, so the first type of soil that we are going to discuss here, the first type of soil is alluvial soil. So let us write down the first type of soil is alluvial soil. Alluvial soil. So what is the transportation agent involved here? The transportation agent involved here is running water. That is, it is being transported by running water, and they are found at rivers and lakes. Rivers and lakes. First we shall write down the note points, and then we shall have a detailed discussion on it. Okay, so the second type of soil that we are going to discuss is lacustrine soil. So it is lacustrine soil. It is lacustrine soil. So the transportation agent involved here is fresh and still waters. Okay, fresh and still waters. And where is it found at? Fresh and still waters. Where it is found at? It is found at ponds and lakes. Okay, it is found at ponds and lakes. Okay, rivers and, this is not lakes. Okay, this is near the rivers only. Okay, not at the lakes, it is near the rivers only. Okay, near the rivers. It could be banks, or it could be the this, what is that, beds as well. Okay, it could be found at the banks or at the beds. So the third type of soils that we are going to discuss about is colluvial soil. Okay, or we can write marine soil. Third, marine soil. So where is it found at? It is found, or the transportation agent involved here is sea water. And where is it found? It is found at the sea shores. It is found at the sea shores. So the fourth type of soil that we are going to discuss is a colluvial soil. Colluvial soil. It is also called as talus. Okay, it is also called as talus, and it is the transportation agent involved here is gravity. Okay, and it is found at mountain valleys. Okay, it is found at mountain valleys. Okay, so the fifth type of soil that we are going to study is glacial soil. Glacial soil. Okay, so it is also called as till. Okay, it is also called as till soil, TILL, till soil. Okay, and the transportation agent involved here is ice. Okay, transportation agent involved here is ice, and it is found at glaciers. Glaciers. Now the sixth type of soil is aeolian soil. Aeolian soil, or it is also called as sand dunes. Okay, and it is found at, or the transportation agent here is wind. Okay, and it is found at desert areas. Okay, desert areas. Okay, now let us have a detailed discussion on all these type of soils. Okay, now talking about the first type of soil, that is the alluvial soil. Now this type of soil, that is alluvial soil, they are found in suspension in the river waters. That is, they have been transported as they are in suspended form. Okay, that is, when they are being transported, they are in suspended form, and as they are being transported, what happens, these soils, they tend to settle down to the beds of the running water. Okay, to the beds of the running waters, and as they settle down, they form deposits of soil. Okay, they form deposits of soil at the beds of the rivers. Okay, and due to these deposits, which are at the beds of the rivers, the type of soil that is formed is called as alluvial soil. I repeat, okay, these type of soil particles are found in suspended form as they are transported by the running waters, and as they are being transported, they tend to settle down, or they settle down to the bottom of the beds. Okay, or they settle to the bottom of the rivers, and as time passes by, more and more soil particles get settled down. Okay, and they form deposits of soil at the river beds. Okay, so these so the deposits that are formed at the bottom of the river beds, they are nothing but the alluvial soil. Okay, so since they are being carried by the river waters or running waters, we can say that they are found near the rivers. That is, they are found at the banks and at the beds of the rivers. At the beds and banks of the rivers. Sorry, okay, I said banks. Okay, banks, and that is, banks is nothing but the sides of the rivers, and at the beds of the rivers. Okay, so talking about the next type of soil now, that is lacustrine soils. Okay, now talking about lacustrine soil. Okay, in the previous case, the transportation agent was river waters. In this case, the transportation agent is fresh and still waters. That is, these soil particles are being transported by fresh and still waters, and as they are being transported, they tend to settle down, or they settle down to the bottom of the lakes. Okay, and when they settle down to the bottom of the lakes, the type of soil that is formed is called as lacustrine soil. Okay, and since they are since we find ponds and lakes to be potential source of fresh and still waters, we can say that they are found in ponds and lakes. Okay, so the next type of soil is marine soil. So in the above two examples, the transportation agent was running water, and in case of lacustrine soil, it was fresh and still waters. Now it is obvious, when it comes to marine soil and the transportation agent being sea water, the soil particles are now being carried in suspended form by sea waters. Okay, and when these suspended particles settle down to the bottom of the seas, the soil that is formed is called as marine soil. Okay, is called as marine soil, and since it is being transported by sea, okay, they are usually found at the seashores. Okay, now talking about collovial soil. Okay, now talking about collovial soil, okay, let me give you an example. Okay, now let's suppose these are the, let me take another color. Okay, now let's suppose these are the mountains. Okay, these are the mountains here. Okay, let's suppose the weathering of the rock takes place at the top of the mountain here. Okay, the weathering of the rocks takes place at the top of the mountain here. Okay, now what happens, the soil that is formed here, that soil doesn't stay there itself. Okay, due to gravity, it has been transported and deposited at the valleys here. Okay, it is transported and deposited by the at the valleys. Okay, so the soil that is being transported by the action of gravity is called as glacial, is called as colluvial soil. Okay, so the soil that is transported by the action of gravity is called as colluvial soil, or it is also called as talus. Okay, so transportation agent involved here is gravity, and since it is being transported at the at the valleys, okay, at the valleys of the mountains, okay, that the soil they are usually found at the mountain valleys. Okay, let me erase this off. Okay, so the next type of soil is glacial soil. So it is obvious that the soil that is being transported by ice is called as glacial soil. Okay, as simple as that. It is also called as till. Okay, and since it is being found at, or it is being transported by ice, it is usually found at the glaciers. Okay, now talking about aeolian soil, okay, or sand dunes. Okay, since in the desert areas, okay, since the desert areas are prone to large amount of winds, okay, or they consist of heavy wind blowing across the area. Okay, what happens, the soil that is present there, okay, that is being transported and deposited elsewhere. Okay, so the soil that is being transported by wind is called as aeolian soil, and since the desert areas are blown to heavy flow of wind, okay, these soils are usually found in the desert areas. Okay, so this was all about the first 6 set of soils, or first set of 6 soils. Okay, so now we have some more soils to be discussed. Okay, so the first of them being Lewis soil. Okay, first soil is Lewis soil. Lewis soil. Okay, now we shall write down the node points first, and then we shall have a detailed discussion on it. Okay, it is uniformly graded. It is uniformly graded, uniformly graded wind blown silt, uniformly graded wind blown silt, that has cementing properties, or it has slightly cementing properties, we can write. Okay, wind blown silt. Okay, so it has slightly cementing properties. It has slightly cementing properties due to calcium compounds. Okay, due to the presence of calcium compounds. Okay, due to calcium compounds, you can say due to the presence of calcium compounds, okay, but when they become dry, okay, they are cementing properties due to the presence of calcium compounds. Okay, but when they become wet, they lose their cementing properties. They lose their cementing properties. Okay, they lose their cementing properties and collapse. Okay, they lose their cementing properties and collapse. Okay, so the next type of soil, that is the second type of soil, is marl soil. Okay, marl soil. Okay, so it is calcium carbonate soil. It is calcium carbonate soil. It is calcium carbonate soil of marine origin. Okay, of marine origin, which is formed is formed by the decomposition of of dead plants and animals, animal bones. Okay, so the third type of soil is bentonite soil. Okay, so we can write it is chemically weathered volcanic ash of, or we can say it is only chemically weathered volcanic ash. Okay, it is generally used as a lubricant in drilling operations, okay, in drilling operations. It is also a clay. And consists of high amounts of Montmorillonite. Okay, it shows high swelling, shrinkage. It shows high swelling and shrinkage and has high plasticity. Okay, let us discuss these three types of soils now. Okay, now talking about loess soil, it is uniformly graded wind blown silt. Okay, uniformly graded soil is nothing but it is a soil mass which consists of particles having all the sizes. Okay, so this term uniformly graded, we are going to study it in detail in the next chapter. Okay, so here I am just giving you some information that uniformly graded soil is a soil mass which consists of particles having all the sizes. Okay, that is all the sizes particles, okay, are present in this soil mass. Okay, and since the transportation agent involved here is wind, it is a wind blown silt. Okay, it is a silt, to be remembered. Okay, so it has slightly cementing properties. Now what happens is this loess soil, okay, as long as it is in dry condition, okay, what happens, it possesses binding properties. Okay, cementing properties is nothing but binding properties. It can bind the materials together, okay, due to the presence of calcium compounds in it. Okay, but it possesses the binding properties only in dry condition. Okay, as soon as it becomes wet, what happens, it loses its binding property, that is, it loses its cementing property and it collapses in the sense there is sudden decrease in volume of the soil. Okay, to understand the term collapse, you all can imagine, okay, if you'll take a heap of cement, okay, if you'll take a heap of cement and if you'll add water to it, what happens is the heap of cement suddenly collapses. Okay, so that is nothing but collapse. Okay, so now this was all about loess soil. Next type of soil is marl soil. Okay, the next type of soil is marl soil. Okay, now talking about marl soil, this type of soil is usually found in the sea areas, okay, or in the areas surrounding the seas. Okay, because since sea is a potential source of water, okay, the surroundings in the sea are usually going to have habitats, okay, habitats of plants and animals. Okay, and when these plants and animals they die off, okay, due to the decomposition of these plants and the animal bones, okay, the soil that is formed is called as marl soil. Okay, and since there is involvement of decomposition of animal bones in this type of soil, okay, it usually consists of calcium carbonate. Okay, it usually consists of calcium carbonate. Okay, so marl soil is usually found in the sea areas and it is formed by the decomposition of plants and animal bones. Okay, so this was all about marl soil. Now talking about bentonite soil, okay, so now whenever there is a volcanic eruption, okay, whenever there is a volcanic eruption, the lava that comes out, okay, over a period of time, this lava tends to solidify, okay, and forms rocks. Okay, now due to the chemical weathering of these rocks, the soil that is formed is called as bentonite soil. Okay, and this type of soil, okay, it is a clay. Okay, it is a clay, and since it is a clay, the particles of this soil are very fine. Okay, and since the particle size are very fine, it can be used in drilling operations. Okay, drilling operations, how? Now let's consider we want to drive a pile inside the ground. Okay, pile is nothing but it is a type of foundation which we are going to study in foundation engineering. Okay, so suppose you want to drive the pile inside the ground. What happens is, due to friction, okay, this pile won't go inside very easily. Okay, so what we do, we just coat it with a layer of bentonite soil, or we coat it with a layer of bentonite slurry. Okay, and then we try to drill it inside so that it goes inside with ease. Okay, so it can be used in drilling operations. Okay, not only in drilling of piles, but it can be used in various other drilling operations. Okay, now it consists of high amounts of montmorillonite. Very important term, montmorillonite. Okay, montmorillonite. Now whenever you'll come across this term montmorillonite, okay, in any of the soil mass, okay, montmorillonite. Okay, so whenever you'll come across this mineral soil, montmorillonite, or if you'll find any of the soils containing the mineral montmorillonite, you should understand that that soil is always prone to heavy or large amounts of swelling and shrinkage. Okay, swelling is nothing but expansion in volume, and shrinkage is nothing but contraction in volume. So whichever soil consists of the mineral montmorillonite, that soil is always prone to high amounts of swelling and shrinkage. So since it consists of high amounts of montmorillonite, okay, it will be subjected to high amounts of swelling and shrinkage. Okay, and along with that, it is also subjected to high amount of plasticity. It consists of high plasticity. Plasticity in the sense the ease with which the soil can be molded. Okay, or in technical terms, you can say that plasticity is the ability of the material to resist deformations. Okay, so if you all remember, you all had done an experiment in your laboratory wherein you all had wherein you all had made 3 mm dia threads out of soil, and you all went on adding water into it until the soil just broke out. Okay, all the or you all will no longer be able to drive it into threads. Okay, so the breaking of the threads, it signified the deformation of the soil. Okay, so plasticity is the ability of the soil to resist deformation. Okay, so this was all about bentonite soil. Okay, now all these terms, that is uniformly graded, silt, and then we have high plasticity, we will come across compressibility, all these terms, shear strength, all these terms are going to be explained in the further part of the subject. Okay, because these are the terms which involves higher level of explanations. Okay, and we are just beginning with the subject now, so you all are going to get to learn a lot as you gradually advance into the subject. Okay, so you all should be patient while listening, and you all should be patient while you are understanding the concepts. Okay, so the next type of soil is tough soil. Okay, so the next type of soil is, this was soil number 4. Okay, soil number 4 is tough soil. Okay, soil number 4 is tough soil. Okay, so talking about tough soil, it is it is slightly cemented. It is slightly cemented volcanic ash. Okay, volcanic ash, okay, that has been transported by wind or water, you can say wind or water. Okay, so the next type of soil is soil number 5 is black cotton soil. Okay, black cotton soil. Okay, now talking about black cotton soil, okay, it is a residual soil. It is a residual soil. It is a residual soil formed from basalt. Okay, formed from basalt, and it contains high percentage of Montmorillonite. Okay, Montmorillonite. Okay, it is dark in color, and good for growing cotton, okay, and it is good for growing cotton. Okay, good for growing cotton. Good for growing cotton. Okay, it shows high swelling. High swelling, shrinkage. It shows high swelling, shrinkage, comma, it shows high plasticity, high compressibility, and low shear strength. Okay, low shear strength. Okay, so the next type of soil is soil number 6 is laterite soil. Okay, or it is also called as red soil. Okay, so it is a type of soil. It is a type of soil that is formed from basalt. No, not basalt. That is formed from leaching. That is washing away of siliceous compounds, siliceous compounds siliceous compounds, washing away of siliceous compounds and accumulation of manganese, or you can say aluminium oxide and iron oxide. Okay, so it is generally found in hilly areas, with humid climate. Okay, with humid climate. Okay, example is you will find them in Western Ghats, or you will find them in northeast areas. Okay, or any other hilly areas with humid climate. Okay, northeast areas. Okay, now talking about tough soil. Okay, now in the previous case we had discussed bentonite soil, okay, which was formed by the chemical weathering of volcanic ash. Okay, now tough soil is formed by the physical weathering of volcanic ash. Okay, that is the lava that was coming out and it was solidifying. Okay, by the physical weathering of that solidified lava, the soil that is formed is the tough soil. Okay, and this soil doesn't remain there itself, it is being transported by the action of wind and water and it is being deposited somewhere else. Okay, so this was all about tough soil. Okay, now talking about black cotton soil. Okay, now what happens is basalt is a type of rocks. Okay, basalt is a type of rock. Okay, and when it is subjected to physical weathering, okay, or when it is subjected to any type of weathering, okay, what happens is the soil that is formed due to the weathering of basalt, okay, it remains there itself. Okay, it is a residual soil, and that residual soil is nothing but black cotton soil. Okay, and this type of soil is also subjected to high amounts of it also contains high amounts of montmorillonite. Okay, it also contains high amounts of montmorillonite, and due to the presence of montmorillonite, okay, it is subjected to high amounts of swelling and shrinkage. I had explained to you all in the previous soil. Okay, it is subjected to high amounts of swelling and shrinkage and it is good for growing cotton. Okay, along with that it also has high plasticity, that is it has high it can be it can resist higher amounts of deformations. Okay, and it has high compressibility, that is compressibility is nothing but the ability to compress a soil mass. Okay, the ability to compress it is called as compressibility, and it has low shear strength. Okay, so we got one more term here, that is low shear strength. Okay, now shear strength of soil, what do you mean by shear strength of soil? Shear strength of soil is nothing but the compactness or the denseness with which the soil is present. Okay, so the shear strength of a soil, it depends upon various factors, such as it depends upon the frictional resistance of the soil, it depends upon the intermolecular forces of attraction between the soil and various other factors. Okay, so we have a whole chapter on this, that is shear strength of soil. Okay, which we are going to deal in the later part of the subject. Okay, so for now we all can say that shear strength of the soil, more is the denser or more closely is the soil packed together, soil particles packed together, more will be the shear strength. Okay, now this was all about black cotton soil. Okay, now talking about laterite soil or red soil. Okay, so this type of soil is formed by leaching. Okay, I told you all in the earlier part of this video that leaching is nothing but washing away of fine suspended and soluble particles from the rock. Okay, so what is happening here is leaching away of siliceous compounds. Okay, washing away of siliceous compounds, but along with leaching one more phenomenon is taking place, that is accumulation of two other minerals, that is aluminium oxide and iron oxide. That is siliceous compounds are being washed away and iron oxide and aluminium oxide are being accumulated in the soil. Okay, Now this type of soil is formed, okay, or this type of phenomenon wherein leaching, that is washing away of siliceous compounds, is happening, and accumulation of iron oxide and aluminum oxide is happening. Now this phenomenon is most suitable to happen in areas, okay, in hilly areas which are subjected to humid climate, okay. So wherever you find hilly areas with humid climate, you're going to find laterite soil, okay. And Western Ghats and northeast areas, okay, are one such areas wherein you're going to have this condition, that is hilly areas with humid climate, and that is why you're going to find that laterite soil is going to exist in that area, okay. So this was all about laterite soil, okay. So now talking about the next type of soil, that is muck soil. This is soil number 7, okay. Soil number 7 is muck soil, okay, muck soil, okay. So talking about muck soil now, okay, it is a mixture of organic, inorganic soil, you can say. It is a mixture of inorganic soil. It is a mixture of inorganic soil and black decomposed okay, and black decomposed, okay, decomposed organic matter, okay, black decomposed organic matter, okay, black decomposed organic matter, okay. So the next type of soil is muck, it is peat soil, okay, it is peat soil. So peat soil is nothing but it is highly organic soil, okay, it is highly organic soil, it is highly organic soil, it is highly organic soil which consists of which almost entirely consists of vegetative matter, okay, which almost entirely consists of vegetative matter, okay. So vegetative matter in different stages of decomposition, and different stages of decomposition, okay, in different stages of decomposition, okay, in different stages of decomposition. Its color may be black, its color may be black to dark brown, that is, its color may be black or dark brown, and it possesses organic odor, okay, and it possesses organic odor, okay. So the next type of soil is loam soil. Peat soil, muck soil, peat soil, loam soil, okay. So it is a mixture of sand, silt and clay, okay. It is a mixture of sand, silt and clay, okay. So talking about muck soil now, okay, it is a mixture of inorganic soil and black decomposed organic matter, that is, it consists of a mixture of organic soil and inorganic soil, okay. Now we came to know that it is a mixture of organic and inorganic soil. But under what conditions does this phenomenon happen, that is mixing of inorganic soil and organic soil? Now I can give you one or two such examples. Like if you take for example, okay, if you consider a river water, it consists of alluvial soil, and alluvial soils are formed from rocks, okay, and the soils that are formed from rocks, these are nothing but, or we can say that alluvial soil are nothing but inorganic soils, okay. So the river water is carrying inorganic soil now, okay. So now what happens in case of a flood, okay, the river water is going to overflow in the surrounding areas. The river water is going to flow in the surrounding areas, and the surrounding areas is naturally going to have vegetation in it, okay, and vegetation is nothing but organic matter, okay. So whenever there is a flood, there is mixing of organic soil with the vegetative matter, that is mixing of inorganic soil in the rivers with the organic soil, okay, in the surroundings, okay. So this is one phenomenon wherein we can see the formation of muck soil. Another example is when the river meets a sea, okay, so a river is going to consist of alluvial soil, that is nothing but inorganic soil, and sea waters, okay, since it consists of marine soil around it, okay, since it consists of marine soil or marl soil around it. Marl soil is nothing but it is formed by the decomposition of plants and animals, and plants and animals are nothing but organic matters, okay, and since it is formed from the decomposition of plants and animal bones, okay, marl soil is a type of organic soil, okay. So the sea water is going to have organic soil and river water is going to have inorganic soil. So the place where a river meets a sea, okay, there will be formation of, or there will be mixing of organic soil and inorganic soil, which will lead to the formation of muck soil, okay. So muck soil is a mixture of inorganic soil and black decomposed organic matter, okay, that is mixture of inorganic and organic soil, okay. So this was all about muck soil now, okay. So talking about peat soil, peat soil is a type of soil which almost entirely consists of vegetative matter, okay. That is, if you consider the decomposition of vegetative matter or any organic matter, the time required for the decomposition of an organic matter is infinite, okay. So therefore this type of soil, that is peat soil, which consists almost entirely of vegetative matter is nothing but organic matter, okay. So it consists of organic matter in different stages of decomposition, okay. That is few of the particles of the soil or few of the or little of the vegetative matter must have been subjected to lower amounts of decomposition, or a few of the vegetative matters, okay, must have been subjected to a little bit higher stage, or they might be at a higher stages of decomposition, okay, and some part of the vegetative matter must have been subjected to even higher level of decomposition. That is, the decomposed matter is in different stages of, or we can say the vegetative matter is in different stages of decomposition. That is, some of it may be in higher level of decomposition, some of it may be in lower level of decomposition, okay. And since it almost entirely consists of vegetative matter, it possesses organic odor, because vegetative matter is nothing but organic in nature, and the color, it may be black or it may be dark brown, okay. So this was all about peat soil, okay. So now talking about the last type of soil, that is loam soil, okay. So loam soil is nothing but a type of soil which consists of a mixture of sand, silt and clay. That is, you take sand, you take silt, you take clay, and you mix all of them together, you're going to get loam soil, okay. So this was all about today's video, okay. So in the next video we will be technically entering into the properties of soil, okay. And until then, stay safe and stay motivated, okay. Thank you.